Hi everyone, I am Sofia Vistus, the counterpart software engineer in tests for the package group. And today we will be doing a little tutorial about end-to-end testing, specifically targeting the package group tests. Today we will be covering this agenda. We will have an overview about how to use GitLab QA tool, how and where are our package end-to-end tests, how to run them in your merge request, what to do if you find end-to-end test failures in your merge request, and how to configure the JDK to run the package tests, run them locally, what are the current limitations, and how to contribute to the end-to-end test suite. So first of all, GitLab QA is a project developed by the quality department, and currently you can find it in this particular link. We have it published as a Ruby gem, and you can quickly install it and have it exposed as a GitLab QA command in your system. This was created to verify that several pieces and several components of GitLab work well together, and to be able to run the QA end-to-end test suite before it actually gets merged to master as a verification that this MR doesn't introduce any potential failures. So the definition for the GitLab QA is basically an orchestration tool that allows you to do black box testing for the framework using both the API and the UI. And you need to have Docker installed in order to use it. I like to think about GitLab QA as a tool with 4 blocks. So basically, the framework block, instance level scenarios, the orchestrator, and the orchestrator level scenarios. These are 4 important concepts to understand when it comes to using the framework and when it comes to developing tests. So the first block I would actually like to talk about would be the orchestrator level scenario. And in this case, we are targeting particular content for package tests. So I'm going to show here briefly a package orchestrated level scenario. So if we want to build a GitLab instance that we're going to run our tests against, we would need to have the package registry enabled, for example. So when we are building our tests, so when we are running this test, we actually have several pieces here. And one important one is this orchestration level scenario, which is defining which configuration should go into this GitLab instance. So this code actually lives within the GitLab QA code repository and not within the GitLab project that we would see, for example, in JDK. This is basically where the configuration where we can store configurations for our different GitLab instances. It could be, for example, to have a SAML enabled instance, or a configuration to have GitLab having the necessary settings for the container registry, for example. So this basically cannot be applied to when we're running in staging, pre-prod, canary, because those are actually predefined and pre-configured environments and so on. We cannot just change the configuration at the runtime when we're launching these tests. So this is one concept. So we have a scenario where we organize the configuration for the GitLab instance, and then we have the orchestrator. And this is basically the GitLab QA where the real magic, and where I think that the end-to-end level really shines, because it does really orchestrate several components that are needed to really test the full end-to-end user flow experience. And we do have the GitLab QA gem that basically does does two really important things, which are spinning up the GitLab QA test container and the GitLab instance. So, and then within the GitLab QA tests container, basically, this is just an image that is built with the latest, say, tests and framework bundled. And this is going to be targeting the GitLab instance that we see here. By GitLab instance, I mean this is a GitLab Omnibus instance that is configured with the orchestrated level scenarios as we are seeing in the previous slide. For example, the test actually will be able to spin up different components such as the runner, which are needed for the package tests, because we actually use a runner to do certain operations such as do, for example, Maven publish. We basically just have a runner and we set up a pipeline, CI, GitLab CI YAML file, and we just say Maven publish, and we are able to just quickly test different package managed clients. It's important to notice that this instances, so these Docker containers that we see here are all within the same test network. So they are supposed to be able to reach out each other. So for example, when we are creating a runner, when the test spins up the runner, we basically also register to the GitLab instance. So it's actually be able to be used by that instance and when it's running the test. So the orchestrator basically just puts up the components that are needed, and it's also possible to run this orchestrator without tests, right? It's just to have this all organized. As we can see here in the options, we have no tear down, so basically means that you just so in this case you would be running the test, and then let's say there would be a situation where you like to debug what happened after the test if there was a failure, and the containers would still be in place, and you would be able to go into the containers and have some logs. And another one would be the no test flag, where basically you just set up this components and this architecture, and you just don't run the tests. So here we have actually a command, GitLab QA test instance image EE with a flag no test. Basically, this is just, saying it shortly. Basically, this is just saying, hey, just fetch the latest EE image. So in this case, it's actually the nightly image, and run the tests that are for this EE instance. In this case, actually, we passed the no test flag. So we're just basically setting it up as a GitLab instance with the Enterprise Edition nightly image. As another really important part, and this is probably the most familiar part for any end-to-end test framework, is that we use the different, these are actually the key points to really highlight in our framework, is we are using page objects. This is basically to encapsulate interactions, and where we can associate selectors to a particular view. We can abstract resource creation. This is actually very useful when we are creating projects that are needed when we are running the tests. Most of our tests actually need a project. So in order to accelerate that, instead of just going and creating it manually through the UI, we can just create it via the API and speed up our test execution. We have, as I mentioned, specific selectors that are used in the associated views, as I mentioned previously. These are the data QA attributes, and basically this was for a separation of concerns, meaning that when we have the front-end code changing and if we would be using classes or other kinds of selectors, basically would be risking to have deprecated selectors pretty fast. And to combat that, we actually just had, we just have this data QA attributes for the end-to-end test framework. We are using flows for the most common actions. This could be login or when we are actually visiting a pipeline. Depends on the context of the tests. But login would be a good example of a flow. It basically abstracts all those tests, such as username input and password input. And then the framework actually follows a logical organized folder structure, which I'm going to show in a minute. And of course, we are following a set of best practices and a style guide for writing the code. Okay, so to find out where the framework code is, this is my JDK, and I am in my GitLab folder. This is yeah, I'm using VS Code. Basically, within the GitLab folder, you will find the QA folder, and within this folder, basically, is the bare bones, the framework that we are using to support the end-to-end tests. And also within this folder, it's the specs that we run are also there. So checking here a bit of what I was talking in terms of structure. Basically, we have resources. These are abstractions in ways we create resources that we need to use throughout our tests. Some of them, for example, are the runner. I'm going to just show here. And this is the runner class. Basically, it's just really setting up the executor image, fabricating this resource. Basically, we can fabricate resources using the API directly. Basically, this is based on the GitLab API available in the docs. And we can also create resources via the UI, but it's preferably that we use the API. We have mechanisms to fabricate it and to remove it via the API. This is for the cleanup after the test run. So this is how a resource would look like normally. We also use frequently the project resource, right? This is mainly necessary to all the tests and sets up a project needed for the test. Another important component mentioned is the page objects. And these are within this page folder. Basically, there is some logical organization about this as well. For example, here for menus, I believe. Submenus, let's just check. Okay, this is this common, but just showing how it looks like. Let me show something related. So with packages, let's see. So this is we have two page objects here for package. Basically, they are, as I was saying, they are encapsulating the interactions. Here you see the declaration of the view, right, and the elements being used. If I'm going to go to this view, I would be able to see these elements as well. Right, I was mentioning that we are using this data QA attributes, so I'm just going to go and find them. Data QA, and yeah, here we see one of the selectors. So we just use the selectors in order to identify elements in the DOM and use them to then interact with them later in the test. So basically, this is just an abstraction on having the view, having the elements, and then how to interact with these elements. In this case, this is where we are listing the packages, and we are verifying if, so not only interactions, but also assertions. if it has a certain element or if it doesn't have a certain element. Another one would be the show. This is also mapping a page, this page basically, and these objects. So in a nutshell, this is how we are using the page object. And then within the test script, we're going to be using these classes in order to navigate throughout the user flow. Another important block, basically this is the most, I think the product of all of this infrastructure is the tests. And particularly, we have two names for it. We changed it a bit interchangeably. We call them instance level scenarios, but basically they are just the test scripts or the end-to-end tests. And for package, basically they are located within the QA specs feature, and then we have separated folders for API tests and for browser UI tests. So tests that use not only, but mainly the UI to do the verifications. And we have also the Enterprise Edition feature separated in another folder. This is actually, we do not have tests for Enterprise Edition for package at this current moment. We are investing in the non-paid features. And I would like to show you where they are located. Okay, so this is where we could find our tests. We are within QA, and specs. Basically, there is also a features folder, and here we have, so here in this level are the non-paid features, so non-EE, Enterprise Edition, test-related specs. So since we are not having at this current moment recording Enterprise Edition tests, I'm just going to open these folder and package. Here we are, our stage. So as we see here, we have different tests for different package managers, as well as a container registry test. Basically, this container registry test is running against staging and pre-prod environments and not in the MR, as I'm going to explain in the limitations in the further slide. Here we have, for example, a Maven repository spec. This is how would a test, an end-to-end test would be looking like. And this is still fairly simple. We are using our spec capybara and some abstractions that we use from the page object and the resource creation. But basically, we would be here, we would be creating the necessary variables. And as I mentioned, we are creating the resources, especially before the test started. So we create a project, we create another project. This is basically to test the Maven, we are testing the group endpoint level. So we have two projects within the same group, and we are just creating these resources here. We create a package. This is basically to be used as a reference to a package created, so we could delete it after the test run. This is here in the after block. So the after block has the logic for cleanup. We're trying to leave and use pristine environments, but also use cleanup in environments, especially when we are running this test in staging and in pre-prod. We want to make sure that we are removing runners if we need them. We are removing projects as well. Yeah, so this is the after block. I'm just going to roll up there. Another important one, this is just creating a runner that is necessary to run the logic of this particular test. it goes and fetches the URI of the GitLab address with a port. Basically, this is just to find out where our GitLab instance is running, and defines a POM XML. In this case, it's needed for the Maven repository test, and establishes the whole parameters here. This is pretty much based on the documentation we have. We have another, so we have two POM XMLs, one for the first project and the second one for the another project. Settings, so this is also a file required by Maven, and we also have another file. The first is the file that actually deploys this package. So this would be in one project, so probably the first project, and then the other project would have a GitLab CI file that would install that published, that deployed package. So these are the files defined. Basically, this is just normal GitLab CI syntax. And this is just a definition of the after block for the cleaning, as we've seen. So this is where the test really is. Pushes and pulls a Maven package via the CI and deletes it. This test case are links for test cases that we are documenting also for failures and for status, the automation status of this test. So the test, basically what it says is like, okay, given that we have a project that we have created, this project up there, just go ahead and commit these files. Basically the deploy YAML, the settings XML, and the POM XML. This is going to go and commit on the first project the necessary files to deploy the Maven package. It goes and visits the latest pipeline, because basically when we are when we commit a GitLab CI YAML file, it's going to just kick the pipeline automatically. So we're going to go there and we're going to click on the deploy job. This is the name of the job defined above in the script. And we're going to just wait for it to be successful. So this basically will tell us if the deployment of the package was successful. There is a verification as well in the package registry that the package was added, an UI verification as well. Okay, and then here we are adding the necessary files for the another project. So this is the other project in the same group as the first project we have seen. And it's going to verify the installation as well. So basically, if this is all successful, it means that the deployment and installation were successful, and we are verifying here. Actually, this is the UI part that I was saying. Basically, this is the navigation to the package link that we see in the sidebar on the left side usually, and we're going to open it and expect that in that index of packages we have that package name. So these blocks that we are seeing here are just basically mapping to those classes we have seen before. Yep, and last but not least, we are deleting the package as well via the UI. And you may ask, okay, so we are removing the package in the after block. Actually, in this one, we are not removing the package, but we should. This is something actually that we should fix here. And the reason we are not doing that is like, just because we are deleting via the UI, we should also reensure that we can remove it via the API in case it is present, just to make sure that we are cleaning up after ourselves. And yeah, there are other scripts, but basically we're just following what I believe is similar syntax to some of the other RSpec tests that we use in lower levels of testing. So this is how an instance level scenario looks like. Okay, so say you have an MR and you are working on an important feature. So you're working on something in the Maven client, for example, and you know that there is test coverage. There is an end-to-end test for this feature, for this package manager, and you just want to make sure that everything is okay, and you would like to trigger this end-to-end test suite in your MR. So basically, it's pretty simple. You just go in your MR and you trigger the package and QA manual action. It needs to be triggered manually. That's the case. Once it actually runs, once you actually go into it, you will be seeing this trigger downstream pipeline link, and this link basically goes through a series of other jobs, and you just have to click on the downstream, the final downstream job for the GitLab to be directed to the GitLab QA mirror project. And basically, this is where all the tests are running within those jobs. There are different jobs there. These basically, they run a subset of tests. Okay, so what happens when you actually see cross instead of a tick? Basically, this means that the job failed, and there could be several number of reasons, but assuming that we have a failed test and not a timeout due to some test environment situation, basically what you have to do is make sure that the failure first has been reported in the pipeline triage issue for that given week. Basically, we have a pipeline triage rotation where two SETs, primary, secondary, per time zone. So for EMEA, America, and sometimes for APAC, we are responsible to look at these failures and to triage them and raise them, try to reproduce them, try to understand if it's a broken test or actually a broken feature. So it's very important that you actually go and check if this failure has been reported yet, and if it has not been reported, please do comment on this issue and notify the DRI. So the responsible, which is basically within that time zone, should be able to see this comment. And if this is actually a failure related to the package tests, you could not only report to the DRI and do comments in the pipeline triage issue, but if you notify the counterpart SET, it can be even faster to just understand what's going on, what is the failure about, if this is a false positive. And if you are yourself adding this end-to-end test and you see it failing, please do require help by pinging the counterpart SCT or by actually reaching out in the quality channel in Slack. It is, I think one of the coolest things is that we can actually run and reproduce with this tool as well when running locally in the JDK. So you could be developing locally a feature, and before, say, you trigger this in your MR by clicking on the package and QA job, it's possible to do it locally. So this is actually much faster because you don't have to build the images and necessary for setting this whole thing up. There are a few things though that are necessary to have configured in advance to run the package tests. These can be actually different for other sets of tests because other sets of tests require different components. For example, the registry would require a registry to be running locally as well. But say that we are running the package folder test, we currently don't have registry tests that are running, that are possible to run locally. And this is something that we can talk about when we talk about limitations. But the things to have in mind, really, first of all, is to set a loopback interface and create an IP that is mapped to a host name. In general, there's a preference for jdk.tests as a host name. Basically, there are instructions for setting this up, also in the docs in JDK. This is mainly to have the ability to launch a runner and to have that communicating with your JDK. Our package tests do need that. And once you have this set up, after doing the JDK reconfigure and JDK restart, you have to navigate to within your JDK folder to the GitLab and then to the QA folder. Ensure that you have the gems installed by having by launching the command bundle install as well, and then it's just a matter of issuing the test command. Basically, Chrome headless is it's a variable that just you're able to actually see the execution of the tests in a Chrome browser. So if you actually would set Chrome headless to true, you would be running a headless test, so you wouldn't be seeing anything, just the execution log in your terminal. Ensure that it is targeting the right host name. So in this case, we have http jdk.tests in the port 3000. Make sure that it is targeting what you have set up. And here we have browser UI 5_package. So basically would run everything that's within that folder. And sometimes we just want to run the test that we are developing or the test that impacts our feature. And these are tags. Tag orchestrator and tag packages are actually tags that we use for running the previous, running these tests in organized jobs, as we've seen in the. So what are the current limitations? Basically, I just would like to say that there are some limitations in terms of setting up components. In this case, as I mentioned before, we have with a container registry. So this means that our container registry related tests are targeting pre-configured environments. So this means that they are running in staging or pre-prod, and not when you run package and QA. This is because it proves to be a little bit more complex to set up the registry in an omnibus instance and running in our Docker network, but we are currently working on it. So for the package itself, basically, we have been able to work with no problems. And I just would like to highlight that. So if you really feel like you want to contribute, more than welcome. And I think a good place to start is either the feature you're working on and add a test, an end-to-end test to it, if it's actually necessary. I mean, we don't really like to add end-to-end tests when we could be testing and doing more robust testing at the unit and at the feature / system level. This is because, of course, the end-to-end tests do take time to run. So I would suggest either start out with the feature you're developing or with the package Epic QA test suite. Basically, this is an Epic where the package team has the tests planned, some of them scheduled, some of them in backlog, but this is what we are working on. Feel free to go and pick up an issue. Open an MR and apply a new end-to-end test template. Basically, this is a very useful template to guide you through the necessary steps that we follow when we add a new test, be it to create a test case link, be it to have handy the style guide and some of the best practices we use. And so feel free to apply it. It's highly useful. And if you actually get stuck, I found out by pairing with a few engineers that it's pretty okay to just tag the counterpart ACT and to just get the things going. Sometimes it can be just a little, a misunderstanding on the code, and we could figure things out together. It would be great to trigger the Pakistan QA manual job to really verify if the test passes and if if it's not introducing any failures on the other tests as well. Request a code review and hopefully it gets merged and go out and celebrate. These are some useful links that we have already available. I highly recommend you to check it out at least before doing opening the first MR. And of course, feel free to add questions. I'm going to organize an AMA for the package engineers and basically to everyone who gets to see this. The invite should be out soon, and I'm looking forward. And thank you very much for attending this little tutorial about end-to-end testing for the package group.